Hello everyone. In this video you will learn about applications of clustering as a wrap-up of clustering techniques. Some typical examples of clustering applications in real life are introduced. After watching this video, you will be familiar to some common applications of clustering. Before we see the examples of clustering applications, we must understand that the choice of clustering method depends on the data or the problem we are dealing with. Here is an example of clustering results when dealing with data samples distributed differently in a 2D feature space. We can see how different clustering methods perform differently depending on the data. You can pause the video and take some time to go through the results. Our first example shows that clustering can be used for image classification. Here you can see the classical open database of MNIST handwritten digits. Using k-mean clustering, the same digits with different shapes can be clustered together. Based on the resulting clusters, we can correctly infer the digits based on the digit images. Note that the labels must be validated manually because clustering itself is an unsupervised and without labels. The second application is mall customer segmentation. This application is also related to how personalized recommendations are offered to customers in nowadays online shopping. In this simplified dataset, the age of the customers, the annual income of the customers, and the average spending score of customers are provided. On the right of the slide, you see how the customers can be clustered based on different annual incomes and different ages. In this way, shopping recommendations can be tailored to the different clusters of customers. Another classical application of clustering uses the famous iris flower dataset. This dataset contains data measured from 3 iris flower species, namely Setosa, versicolor, and virginitza. 4 types of data were measured for the 3 species. The length and width of the sepal, and the length and the width of the petal, all in centimeters. On the right of the slide, you can see how the 3 species can be classified by k-means using 3 data types as the input, which are the petal length, petal width, and sepal length. Next, clustering can also be used to chart the evolution of animals. An interesting example would be answering the questions, are giant pandas closer to bears or raccoons? To answer this question, we can use the DNA sequences of giant pandas and other similar animals to calculate the similarity or dissimilarity between them. As a result, we can generate this dendrogram using hierarchical clustering and identify that pandas are closer to bears. Finally, we can also use clustering to track viruses that affect our daily life. On the left, we can see a dendrogram generated by hierarchical clustering for finding the animal that gave humans the SARS virus. This dendrogram is based on the similarity of SARS virus DNA sequences, considering the virus mutation rate among different animals and humans. On the right of the slide, researchers used the dendrogram to visualize and track the COVID-19 infections across different countries. In this video, we learned that the selection of the clustering method depends on the data or the problem we're dealing with. We see some examples that clustering can be used for image classification, customer segmentation, flower species classification, charting evolution, and tracking viruses. Of course, there are many other applications in addition to what we presented in this video. We should also be aware that in nowadays practice, an advanced and improved version of the basic clustering methods such as k-mean clustering are often used to solve our problems.